Alright, so this week 8 of our lessons, we are looking at namespaces and exceptions. We also we are going to learn about namespaces in C++ and understand compilation and program structure. We are also going to understand the usage of the header files in C++, and we are also going to learn about exceptions. So basically, namespace is a feature that provides a way to group related identifiers such as a variable, functions, and classes under a single name. It provides the namespace where we can define or declare identifier, that is a variable, maybe a method or a class. In essence, a namespace defines a scope, and in namespace definition it begins with the keyword namespace followed by the namespace name. Like this is the structure of namespace. Basically, this is how it looks like. You begin with the keyword namespace and your name and your namespace you want, and the name you want to give to your namespace, and these are the parameters you give it. So basically, it looks something like this. Your namespace, you declare namespace, and here we are saying our namespace should be called programming, and it should have this inside. And this is how to access its members: namespace name, double column, and the member name. So here we are defining a namespace called programming, and this is how it is. We have our namespace here and our programming, which is the name we want to give our new namespace we are creating. And we are saying inside this we hide this void function, and this function should contain this. It should print out, give us inside programming namespace, and it should end it. So this is basically a basic way of creating a namespace in C++. So this is how you access the members. Remember, this is one member per the structure. The structure we have here, the type and the member. So here we have the type void and the function and func, which is our first member here, and it contains this. So to access it, we use programming and double semicolon with the func, which was inside our defined namespace. So the namespace with using directive. This directive tells the compiler that the subsequent code is making use of names in the specified namespace. So here, for instance, namespace and our programming name as usual, and our first member, our first parameter is here. So using namespace programming, when you want to use a namespace without you doing like this, like what we have here, if you don't want to each and every time doing it with programming and double colon the func, you can just indicate at the very top of your page using namespace programming and just call it, and it will work at the same way you just put the programming in line with it. It will work. And for instance, this std is also a namespace, so usually we also indicate it so that we don't do this. But in case we don't do the std, this is how we do it. So here you can use it like this also, and call everything at the beginning using programming and the function. So we specifically want to use this in our programming. And these are the types of namespace. You have the inbuilt namespace, you have the inline namespace, anonymous namespace, and the global namespace. And the inbuilt namespace is a namespace that are part of C++ library, which contains most of the built-in functions, objects, and classes. It also avoids conflicts between user-defined and library-defined functions or variables. The std namespace is a namespace that is part of the standard library, which contains most of the standard functions, objects, and classes like cin, cout, vector, etc. It also avoids conflict between user-defined and library-defined functions or variables. So inbuilt namespaces, here is what we are looking at. We are looking at std, namespace std. This is a default std in the standard library of C++, and it contains cout. So since we declared it, we don't have to use it this way, or is it this way? here, since we didn't declare it, we have to use it this way, or else the compiler won't understand this. But here we are including this namespace, so we can just call it out like this. And a namespace where its members are accessible directly without using the namespace name. That's inline namespaces. And inline, this is how it is, a basic code of inline namespace. Inline, a namespace, and the inline namespace as your name, and your void, your members are also inside the curly braces of it. And in this one, you direct access due to inline space, you just call it like that because it's inline. You call it. And anonymous namespaces, that's a namespace that does not have a name, called an anonymous namespace. It ensures that the entities in the unnamed namespace are limited to that file. So here like this, this is how you declare an anonymous namespace. That means it doesn't have a name. You just use the namespace and you open your brackets and do it, and do whatever you want to do inside. But remember, this one does have a name. This particular namespace doesn't have a name, so you can't access it outside this file. And basically this is how you access it. And we are going to learn about exception handling. And exception handling is based on keeping the normal functionality of the program separate from error handling. The basic idea is that errors occurring in one particular part of the program are reported to another part of the program, known as the calling environments. The calling environment performs central error handling, and the part of the program that performs central error handling is the calling environment. In the calling environment is referred to as an exceptional handler. So, component of exception handling, there are two parts for implementing exception handling, and the part of the program that can throw exceptions, and the exception handlers that will process the various exception types. So we have the try and catch blocks, and here the C++ provides an inbuilt feature for handling exceptions using try and catch block. It is an exception handling mechanism where the code that may cause an exception is placed inside the try block, and the code that handles the exception is placed inside the catch block. So here it is. So here we are saying this, basically the syntax of it. Try this, and it might throw an exception, and then you catch the exception over here. So throwing exceptions. Throwing exception means returning some kind of value that represents the exception from the try block, and the matching catch block is found using the type of the throw value. The throw keyword is used to throw the exception. So here try and throw val, then catch and the exception type, and this is the name you are giving it, and this is handling the exception. The code over here is handling the exception. So here it throws it, this side catches it, then it handles it over here. So these are the types of throwing exceptions, and there are 3 types of it, and these are the built-in types, the standard exception and the custom exceptions. So here we are looking at the built-in types. We are saying you should try this block of code. If x, we are declaring x to be 7, and we are saying if x modulo 2 is not equal to 0, then it is throwing an int, so throw -1. And here this is the catching side, and we are saying catch the int e, then it should print out exception port, the e. It will cut it from here. This one is throwing -1, and this one is receiving it into e, then to display it. And this is throwing standard exceptions, and standard exceptions are the set of classes that represent different types of common exceptions. All these classes are defined inside std except header file, and mainly derived from std exception class, which acts as the base class for inbuilt exceptions. So here basically C++ exception hierarchy. We have the logic error exception, we have the bad alloc exception, we have the bad pass, bad function call, and the runtime error. And the logic error is basically the invalid arguments, maybe domain error, length error, out of range error, and the runtime is the range error, the overflow error or underflow error. So throwing standard exceptions, we are looking here, we are saying vector this, and we are giving it this vector, and we are saying try, you should try this block of code and catch this block of code. So it should it should locate 10, and it should catch this. Since this one is not inside here, we can't locate this one. We should catch out of range and E. Then we are saying it should print out quote an exception with this function over here. And the benefits of exception handling: separation of error handling code from normal code, and functions or methods can handle only the exception chosen, grouping of error types. So separate compilation. A function definition is a function declaration in which the body of the function is presented. So a structure, a function definition includes a return type, a name, a parameter list, which is optional, and the body enclosed in curly braces. So this is how a C++ programming works. This is how it processes. First the editor, then the processor, then the compiler, and all the library tool is all in the linker. Then it will load it and execute it. We are going to talk about header files now. And C++ offers its users a variety of functions, one of which is included in header files. In C++, all the header files may or may not end with the .h, and the header files in C++ are basically used to declare an interface of a module or any library. So the components of header files, it may contain function definition, data type definition, or macros. So here, this is a syntax. To use a header file you use the hashtag in the include, then you put in less than and greater than the file name .h. So for files already available in system or default directory, this is how you do it. And also you use hashtag include file name.h with the double quote for files in same directory as the source file. So here, if the header file is in the default directory, you use a greater than and less than to keep it. But for here, if the header file is in the same directory as the source file where you are coding, then you can use the double quotes to keep them. And this importing header files into the program with the help of a preprocessor directive, which is the hashtag include. And these preprocessor directives are used to instruct the compiler that these files need to be processed before compilation. There are two types of header files in C++. We have a standard header files, that's pre-existing header files, they're already there, and we have user-defined header files, and these ones are created by the users themselves. So standard header files or pre-existing header files, they are the files that are already available in the C++ compiler. We just need to import them, and the standard header files are part of the C++ standard library and provide commonly used functionalities. They contain the declarations for standard function, constants, and classes. And these are basically examples of standard header files. You have the IO stream, you have the CMAC, the string, the CRNO, and the vector. And there are more, not just this. These are not only the standard header files, there are more. You have user-defined header files, and these files are defined by the user and can be imported using the hashtag include with the double quotation as I mentioned earlier. And these are mainly used to encapsulate our own functions, classes, or declarations so that we can organize our code and reuse our code by separating it in different files. Writing user-defined header files. Write your own C++ code and save it with .h extension. This is how int, you are declaring something here. You are saying you should give it an integer, sum of two numbers, that's the name, and this is it. Then it should return a plus b. So it will take, this one will take a and to take a parameter b, then it will return the summation of them. And so we store this, we will save this one with sum.h like this, and we are saying it's inside our current directory where we are writing our code here. So we are saying int main as our main function, then we are giving the two numbers, a is 13 and b is 22. So we have to print out sum. The sum is sum of two numbers, a and b. Remember, this is only possible because we included our sum.h, which is this, and here we are picking the function, this function from this file. You understand? So creating a header file. A header file should not contain ordinary function definitions, data definition, example int a, aggregate definitions, example short tbl is equal to this, and unnamed namespace, unnamed namespaces, example namespace blah blah. So using directives, example using namespace full. Programs. A program is a collection of separately compiled units combined by a linker, and every function, object type or anything else used in the collection must have a unique definition. A program must contain exactly one function called main, and the main computation performed by the program starts with the invocation of the global function main and ends with the return from main. The return type of main is int, an integer value, and the syntax is your int main and everything you want. So program termination, there are numerous ways to terminate a program: by returning from main, by calling an exit, by calling an abort, by throwing an uncaught exception, by violating no except, by calling quick exit. These are basically ways you can terminate from a program. So this is our week's lecture. Thank you.